Thank you. If we can take our seats, this session is around affective analytics. And as we have noticed before, we only have one paper for this, a full paper. The other paper, due to unforeseen family circumstances, had to return home. I'm Grace Lynch, and I'll be chairing the session today. So as a full paper, it'll be 20 minutes, and then 10 minutes for questions. Are we ready?
Everyone ready?
We're ready? We're pumped?
I guess I need to
Here we go, Zach.
lock and load with my sling here. Okay. Actually, it feels so funny. Thank you, Grace. So the paper I'm presenting today is with Sujith Gowda, Ryan Baker, Supreeth Gowda, and Maria San Pedro from Massachusetts Institute of Technology, Worcester Polytechnic Institute, where most of this data comes from, Columbia University, and that's our collaboration. The title is Investigating How Affect Throughout the School Year Predicts End-of-Year Learning Outcomes. And I'm just going to begin with the research question that we're after with this, this first work of the collaboration, which is, what is the correspondence between students' affect during the school year and their end-of-year state test scores? So I want you to think about this for a minute, which is, these are the affective states and behavior states, the last two being behavior states, that we're going to measure. And just assume that you get these measurements for every second of a student's presence in the classroom for the whole year. And then at the end, you have a summary of each of these categories for each student. So if I'm relatively low in terms of engagement during the year, would you expect me to have a relatively high or low state test score? And the state test will be in math. So maybe if I'm more engaged, you might assume, how many people would assume that a more engaged student will have a higher state test score than a less engaged? Okay. So how about boredom? If I am more bored than most of my other students, should I have a higher test score? Yes? No? Okay. So maybe the yes is, well, yes, you should have a higher score because you're one of those students who are really good and all this stuff is boring you. This material, you know, you're too good for all of this, which we all know how that feels like, right? And then we have confusion, same kind of thought process could go on there, frustration, and then off-task and gaming. Those don't sound good, but we're including them to see for ourselves. So I want to provide a little context, and some friends of mine annotated this with smiley faces just in case there was some language issues. You can get the idea of the affect through the smiley faces there. But I want to provide some context, which is performance during the year has been correlated to end-of-year state test outcomes. One of colleagues who have done this is Ming-Yu Fang in 2009, where she looked at tutor performance throughout the school year, where students would use the tutor almost every day. Excuse me, it was once a week. And then performance on the tutor would be correlated with the end-of-year state test outcomes, and they would compare use of the tutor to predict end-of-year outcomes when the tutor gave no feedback, so emulating just testing students throughout the school year versus giving feedback and letting them learn. And the result there was that you can predict just as well if you let the students learn. In fact, you can predict the state test pretty well, so maybe we shouldn't even give a state test since the tutor information is giving you the information you need for the test. But so that's been done. What hasn't been done is answering what part of the outcome story does affect tell. So we know a little bit of the story that's told by during the year performance, correctness performance on the tutor, but how much of the story of state test outcomes does affect tell? And so why study this? Well, it's not studied in the literature, so it's this unknown. So from a scientific point of view, it makes sense to maybe look into this and see if there's something to be discovered. But teachers have known this for a long time, the importance of affect, the importance of a student's mental well-being and emotional well-being, but it hasn't been backed up with numbers. So that's a little bit of the background. Now I want to try to motivate, well, why is this important? Scientifically, we don't know the answer, so we should find out. But why is this important in a greater sense? Well, why is just measuring affect important? Well, affect could be an important state that could tell the story of what type of interventions are right for a given time and in a given state. So if I'm bored, you might want to give me condition A, and if I'm confused, you might want to give me condition B. So paying attention to the interaction of affective state and experiments could give you a bigger effect size. It's also the case that if the virtual learning environment knew your affective state, let's say just engagement or arousal or attention, the virtual learning environment could decide, oh, you seem to be fading, let's tell you to take a break and come back in 20 minutes instead of waiting too long where you're completely zoned out and it'll take an hour for you to come back to full strength. And it could also provide a valuable signal to teachers, just letting them know information that they can't look at all at the same time. Teachers are expert affect detectors, but they can't see every student's affect at the same time. So propagating the affective states that are maybe dangerous or that need to be intervened on, I shouldn't say dangerous, but the top most confused students right now could be important. But so more specific to what we've done here, why is it important to measure affect correlation with state tests? Here I'm saying just measuring affect, but why measure affect and correlate it with state tests? For one reason, this is a very high level reason, but I think it's applicable, is that you talk to a lot of K-12 teachers right now, and there's a lot of teaching to the test. There's state standards, there's Common Core coming up, and teachers need to make the grade in that sense, and so there's a lot of worry about teaching to the test that's been around, and a lot of concern that not enough time or not enough focus at the policy level is given to them to help students in other non-math skill ways, for instance, grit and other things. So I want to bring in a quote from Paulo from his talk yesterday, which is we teach what we can measure. So we can measure state Common Core standards, we can measure state tests, but if we can measure affect and we can compel that affect is a strong correlate to state test outcomes, then perhaps that'll allow teachers some sort of support to teach to those measurements, that is to teach grit, or teach that it's okay to be curious, or to experiment, or to fail a little bit, or to be frustrated. So at a very high level, this is why it might be important. So how are we going to do any of this? I'm saying we're going to measure affect during the whole year, and it sounds great, but we're not going to have observers in a classroom the whole year labeling affect. So how do we do it? So we code a sample of students with affective labels while using a tutor, and I'll talk more about that tutor soon, in classroom field observations. So these are human-coded affective states. And then we machine learn, or we take those affective labels, and then we find the corresponding tutor log data associated with them, and create features from that log data, and then learn a function mapping from those features to the affect labels, and then apply that feature transformation to the entire data set. So basically, we learn how to detect students' affect from a sample of students and then apply that detection to the out-of-sample students. And then we collect the end-of-year state test scores that correspond to the students who use the tutoring system, and we observe the correlation between the raw affect measurements and the end-of-year scores and proficiency categories. And we have 2 years of this data, so we repeat for a second year. So I started just saying we're going to measure a student's affect throughout the whole year. It's only going to be during the time that they're using the tutoring system. So that's the scope of this study. So the tutoring system is the assessment system. It's a web-based mathematics tutor. You see a screenshot of it over there. It's primarily for algebra and geometry. And I guess the most important thing here is that there are two types of questions, what we call original questions, which are based on previously released state test items. And you see that at the top is a congruence question. So that's a main question that students try to answer from a previously released state test item. And then if they get that wrong or they ask for help, they're given what we call scaffolding, which is a sub-question that breaks that main question up into steps. And the assessments team has created this pedagogical tutorial assistance here. And there's also hints related to the question if you want it. So you have the original question, and then you have the scaffolded question, which is a sub-question. Okay. And the types of problem sets that are in this study are random order continuous sets. So a teacher will assign a problem set, and for the period of time that the student is in the lab, she will get random items from that problem set, which includes a very large pool of items. But there are also mastery and skill builder sets within the system now. So a little more specific on coding the students during the field observation. So 2 expert field observers chose classes to attend from a few schools that use the assessments tutor in rural and urban areas. The observers would code students one at a time for 20-second intervals, which we call clips, and label the affective state being exhibited during that interval. So we did tests for inter-rater reliability between the experts, and that was tested by looking at the same students for 51 intervals and then comparing the ratings. Among the affective states, the 4 affective states that I listed, there's a cap of 0.72, which is much higher than chance. It's pretty good. And then for the behavior states, the off-task and gaming is 0.86, which is very good. So inter-rater reliability looks good enough. They have similar opinions on what affect and behavior is. And so they observed the rest, and the rest being around 3,000 field observations made over 229 students. So that's our sample. So now we have the sample, and the sample looks like this. We have the student, we have the time that they were observed for, and the label that was assigned to them. So we're going to use some methodologies from Baker et al. In 2012 that was applied to the cognitive tutor and apply it here, whereby we do this sampling, we create features, and then we use a common suite of machine learning classifiers to find the mapping of tutor features to the label. So we start with field observation labeling of students, so that was step 1. Step 2 is to create corresponding tutor features for the label in that time interval. So I'll show you what those features look like. But step 2 is to fill this this table in with features, and this could be 5 features, it could be 40 features, and then learn that mapping of those features to the label from our sample set of 229 students. So here are some example features that were chosen using stepwise regression. So we use stepwise regression to keep adding the most significant features for prediction until adding a feature no longer improved our fit. Then we take those features and include them in the more complex classifiers to label the affect. So this was feature selection was done with stepwise regression is what I should say. Here are some example of engaged concentration features chosen. Number of correct answers during the clip, which is during the 20-second period. The proportion of actions where the student took over 80 seconds to respond. So maybe that indicates if you're taking longer, you must be concentrating, if it's not too long perhaps. Whether the student followed scaffolding with a hint request, etc. Some boredom, from features of boredom, total number of actions. I suppose if it was very low, you might indicate boredom. The total time spent on the last action before the clip and the first action after the clip. The student's history of help requests and correct answers. And then some features that were indicative of frustration. Percent occurrence in the past of incorrect answers on a skill. The largest hint count in the clip of problems done. So maybe a very high hint count might indicate frustration, but I'll let you browse through the paper for a comprehensive list, and then we have confusion features. Let me just read off a couple. Total number of consecutive incorrect actions for that clip, number of hints used for that clip, number of correct actions in the clip, and then off-task features and gaming features. By the way, gaming is a behavior whereby a student tries to get the right answer without thinking at all. So in assessments, gaming behavior would be clicking through all of the, answering the question wrong, answering the subparts wrong, asking for hints until they're told the answer. Because you'll always be told the answer in assessments if you ask for enough help. But fortunately in the system, the teacher will be alerted to the fact that the student saw the hint that had the answer in it. So they should be disincentivized to do that. But gaming is when you're just trying to get through the system. So we applied the 8 classifiers to each affect state with the hypothesis that a different classifier might be better for predicting each state. And I'll let you look at the paper for which classifiers were chosen for which state, but the average A prime was around 0.7, and kappa values were above chance but lower. They were from anywhere from 0.22 to 0.50, and kappa is what we chose when choosing the classifier. So now we have this mapping of features to affect labels, and we're going to create these features across not just those 229 students, but all the students in our data sets, and label each action with an affective state that was trained using our classifier. So it was 629 students from 2004 to 2005, 764 students from 2005 to 6. So this is a long time ago, but we used these because we had state test scores for the students during these years readily available. And the state test was the Massachusetts Comprehensive Assessment System. We got the scores from the state, and it samples 39 state standards back in that year across 29 multiple choice test questions and some short answer problems. And the total raw score maximum was 52. So the goal is to correlate affect with state score, but affect needs to first be summarized for each student because we want to correlate a list of numbers to another list of numbers, and we're going to correlate a list of engaged numbers for every student to their state test. So we want to summarize their affect during the year. And so to do this, we do a weighting where if I'm trying to calculate Trisha's summary board state during the year, it won't just be an average of their probability of board during the year. It will treat each skill equally. So if I'm very bored during Pythagorean theorem and only a little bored during addition, even if I spent a lot more time on Pythagorean theorem, it's still going to weigh them equally. And the idea behind that was that the state test samples skills equally. So there's probably a better chance of seeing a positive correlation to the state test if we treat the skill weightings equally. So there's a little PC to Mac conversion artifact there with the offset, but that's okay. So here are the results of the correlations, and let me describe this. Here are the affective states and the 2 behavior states. And then original and scaffold are the different problem types. So original is when the student's trying to answer the question correct on first attempt, and the scaffold is when they're getting help, remediation. And then we have 0405, which are the correlations between that summary of engagement and the 0405 test scores for those students, and then the 0506, and the same for the scaffolds. So it's a lot of numbers, so I'm going to draw your attention to a couple. Sorry for the offset there. But what I'm trying to draw your attention to is engagement and gaming. So they had the strongest signals in terms of correlation. If you were engaged, so those of you who raised your hand and said, yes, engaged students should have a positive correlation with test outcomes, you were right. And gaming, I was right there too. That's not very good to game. That's the highest negative correlation. So the other thing there's two other things on this I want to draw your attention to. One is boredom. And the interesting thing with boredom is that, so who said boredom was positive with state tests? And who said boredom was negative? You're both right. Because it's negative if you're bored during the original questions. So if you're trying to answer correct on first attempt on the original questions and you're bored, that's a bad thing. Because maybe you should be paying attention. If you get this wrong, you go into the scaffolding. If you get it right, you get to move on to the next question. But if you're bored on the help questions, maybe you messed up. I'm just coming up with explanations here that we haven't looked into. But if you're bored on the scaffolds, maybe you knew it and you're bored with the help. And then the last thing I want to point you to is confusion. And this was maybe the most interesting result here, which is that it was a similar interaction, where if you were confused on the originals, that wasn't good in terms of predicting your state test or correlating to the state test. But if you were confused on the help, that wasn't bad. And there's some evidence in the literature that confusion is good if it's on items that resolve your confusion. And it's could very easily be classified that scaffolding questions are meant to resolve confusion or at least lead to learning. So there can be positive confusion. I'm out of time, so I'll just say you can look at the paper for these graphs here. Maybe I'll go 2 minutes into the question time. You can look at the paper for these graphs, which just plot the summary of affect for the different proficiency categories, and the state maps the raw score into proficiency categories. If you're advanced, you get a state scholarship. If you're failing, you don't get to graduate high school. So the categories definitely mean something. And without looking at the magnitudes, you can see the trends here where frustration goes up the more advanced you are. So frustration was a positive correlation. Students who are more frustrated tend to score higher. And that was on originals, and scaffolding is similar. Lots of frustration on scaffolding, or I should at least say it's still the positive trend. And then you see the negative trend with gaming, which indicates the negative correlation. So the contributions here, affect during the school year has strong correspondence to state test outcomes. And also what we did here that hasn't been done before is to look at the difference between affect correlation during, or just to measure affect during original question answering and scaffolding. And it does make a difference. There's a positive correlation with confusion on help, but negative on originals, and positive for boredom on help, but negative for boredom on originals. And it suggests affect is an important factor in state test achievement. Thank you for your attention.
Thanks. Some questions for Zach? Way up the back.
Thank you, Zach. 2 questions. The first one is, in those clip segments, if the student was frustrated and then solved the problem and then moved into happy or something else, how was it coded when there was a state shift during the clip?
The first affective state of the clip was used.
Okay, thanks. Can you say a little bit more about the role of the stepwise regression in the overall process? And I have a related question there, which is stepwise is usually highly sensitive to non-normality and outliers. Did you do any kind of transformation or regression diagnostics around it?
I don't believe we did any treatment of the data for the stepwise regression fit. I can answer how it was used in the methodology, which was it was used for the feature selection before the 5-fold cross-validation. the five-fold cross-validation being to choose the candidate classifier that was best for the affective state. That could be improved potentially by using a classifier that's a multi-state classifier. So for any given time, it can predict which of the 4 states you're in instead of a separate classifier for each. That still might not be perfect because each state could still have a different distribution of errors for each one. So there still might be a bias towards one state. But there's certainly a lot of future work to hone in the accuracy of these models.
Yeah, hello, thank you for your talk. Just a question, you were analyzing in tutor time. Did you take some precautions to say, okay, we don't care how they did off tutor, were they learning, what was the effect of their learning outside of your system on this final score?
So that's not something we measured outside of the tutor learning. Presumably there was lots of outside the tutor learning. The tutor here was prescribed, I think, once per week. And it's perhaps an open question how much affect in the modality of a virtual learning environment corresponds to affect in the modality of sitting in a classroom answering questions or doing homework, paper and pencil homework at home. But in as much as it's perhaps similar, it was a sampling of their whole time during the school year. Good question.
Zach, can I get you to come around front?
Sure.
Get the next one ready
Yeah.
so you can keep asking questions?
Good deal.
Okay.
What were the operational definitions of the affects? Were they, you got agreements on them, but what was it that signaled that a person was frustrated or et cetera?
So I think you're asking, when I listed the selected features for each affect, what were the actual sort of ranges of values or the magnitudes that were correlated with that affect?
No, how do you know if I am frustrated? What do you observe about me that indicates?
Oh, well, you'll have our field observer right there can tell you.
Oh my goodness.
So we use the BROMP, B-R-O-M-P protocol for affect coding, which is a holistic coding method, which instead of trying to get single signals of things like boredom, has the coder try to make a holistic judgment based on posture, facial expression, interactions, and various other things. We find that when we use that approach, as opposed to trying to do something like Ekman's thing, where you try to define exactly what it is, you get iterator reliability about double. So people are good at telling when somebody's bored. They're bad at saying why they think it is.
Just time for one more question.
I'll actually follow that up and ask you the question that you thought that Philip was asking you in terms of.
That's unfortunate because I don't know that. Maybe one more quick one.
One more question. Everybody's tired from last night. All right, thank you very much.
Thank you.
Zach. It's very interesting. Thank you. Shane, you're the chair for the next session.